Time is a difficult concept to understand. There is a famous saying of St. Augustine when asked, "What is time?" he said, "I know what it is. When you ask me, I don't." Time is fundamental to our lives, we say. Time is money. I don't have enough time. Time flies. For thousands of years, philosophers and scientists have struggled to understand the phenomenon of time. For the last 100 years we have known about time dilation, or the slowing of time with motion and in gravity, yet the real understanding of time has evaded us. I am presenting here a clear solution to the enigma of time, which brings to light the reason behind many predictions of special and general relativity, such as why time slows with motion and in gravity, what is the cause of gravity, and why it is only attractive. Why do gravitational fields curve space? What is the cause of inertia and length contraction, and why there is no twin paradox? Time presents to us in many ways. We measure time, keep time, meet, and greet in time, and our daily lives are completely wrapped around the onward rush of time. We perceive time as past, present, and future. Events in time are always accompanied by a mental image of a place suggesting that time is a dimension. This has sprung a whole culture around the concept of time travel, leading to numerous science fiction stories and movies. In physics, time plays a role in measuring motion and forces. The many facets of time should suggest that time is an emergent phenomenon arising from some underlying process that we need to identify. The most significant breakthrough in the understanding of time occurred about 100 years ago with Einstein's theories of special and general relativity, in which he introduced the concept of slowing of time with motion and gravity. Einstein also showed that large masses curve space and there is an increase in mass with acceleration by application of a force. These discoveries of Einstein provide the necessary clues to solving the riddle of time. One of the earliest devices to measure time was the sundial, which used the sun's motion as a standard of measurement for time. The use of units like seconds and minutes, which are radial angle measurements in geometry, may point toward the primary connection of time measurements to the radial motion of astronomical objects across the sky. Once we started using precise timekeeping devices like digital clocks and time based on atomic oscillations, the time's celestial connection was lost. Now the whole world's time can be synchronized with atomic clocks, and time has developed a life of its own. When we measure the speed of a car, we seem to be measuring speed with something abstract called time. We are just comparing a known motion of the sun with an unknown motion of the car. Time is a way to compare or describe different kinds of motions like the speed of light, how fast the heart pumps, or how frequently the Earth spins around its axis. These processes can be compared directly with the sun's movement or another standard motion without any reference to time. Time may have no independent existence. It is just a common unit of motion, making the world easier to describe. Time is a real phenomenon, a continuous change through which we live. Time becomes evident through motion, sunrise, sunsets, night and day, the changing seasons, and the movement of the celestial bodies all indicate continuous change. The aging process is a reminder that molecular motion and interactions are also at work and are a part of time. Another aspect of time is the presence of motion of particles like the photon and motion at the atomic and subatomic levels. An often overlooked but essential element of time is that forces also act in time. Visualize two objects, one moving in orbit around the other. Now suppose from our distant observation point of a fixed time, we observe time to get slower in the area where these two objects are moving. We expect to see a slower motion. We also should find proportionally weaker gravitational force, otherwise the objects will get pulled together. If we observed a faster time, we expect to see speedier motion and stronger gravity to keep the objects from flying apart. While with zero time, the motion will freeze, and gravity will become zero. As this thought experiment also can be extended to particles held together by electromagnetic forces, we can say that time involves both motion and forces. The present is unique. It is the gift of living and feeling the reality of existence. Our interaction with the world in the present creates our memories, which then immediately become part of the past. We live in the changing present in which the future continuously unfolds. The present is a fleeting moment, a narrow point on the timeline encroached by the past and future. Present resembles the sharp point of a recording laser or needle. It may be the mental awareness of recording memory as it is being perceived and inscribed into our neurons. Unlike the present, we see the past and future as measurable durations of time. Past historical events, a meeting or a wedding reception, are all measurable durations or extensions in time, just like recorded material on tape. This similarity suggests that the past is more like a recorded memory, while the future can be compared to an unrecorded tape. Another observation pointed out by philosopher McTaggart was that historical events also have the same time characteristic as stories that are creations of the human imagination. Both stories and historical events contain the time concepts of earlier, the later, the past, the present, and the future, suggesting that the past is nothing more than a memory of events. The future appears to be a projection created by our past experiences, stored in our memory. The fact that the present, which gives us the most realistic feel of time, cannot be measured while past and future can be measured as durations, suggests that our perception of time as a place where we could go, that is, the dimensional view of time, is an illusion. People like us who believe in physics know that the distinction between the past, the present, and the future is only a stubbornly persistent illusion. Albert Einstein. Every past or possible future event also has a place-like feeling to it. Timescape feels like it is a place where it may be possible to go. This dimension-like view of time has spawned numerous science fiction stories and movies on time travel. This view of time suggests that dinosaurs are still alive and roaming the Earth in some other time dimensions. It also suggests that there are multiple copies of us and the whole universe smeared across multiple dimensions of time. In special relativity, the block universe view of time arises from an interpretation of the Lorentz transformations equation known as the Rietvik-Putnam argument, or the Andromeda paradox. By this innovation of special relativity, just walking on the Earth toward or away from the Andromeda galaxy, which is 2.5 million light-years away, we can shift our line of simultaneity so that our time can be in sync with either past or future beings living in Andromeda. This interpretation of special relativity suggests that past and future exist as a part of the block universe. Lorentz's transformations have not been proven experimentally, and this interpretation of special relativity cannot be verified. Other special relativity predictions such as slowing of time, gain in mass, and length contraction with motion can be derived without Lorentz transformations and are experimentally verifiable. In the block universe, time is laid out as a timescape similar to a landscape, and there cannot be free will. If the timescape is already laid out, then what caused it to be laid out, and what causes our conscious experience to move through this timescape? Also, why can we not willfully move our consciousness anywhere, anytime? The concept of time in the block universe leads to some interesting conclusions. The universe should have many future civilizations millions or billions of years more technologically advanced than us. At least some of these civilizations should be capable of traveling through the block universe, and we should have seen some evidence for that, unless there is some law of the universe that prohibits time travel. The block universe also leads to time travel paradoxes like the grandfather paradox. If the universe with its past, present, and future exists simultaneously as the block universe, then all of it, from the Big Bang to the infinite future, should have begun at the instant of the Big Bang. There is no doubt in the minds of physicists and astronomers that this event occurred about 13 billion years ago. Also, the block universe concept of time is considered a natural outcome of the Lorentz transformation. However, the concept of the block universe may be at odds with the origin of the universe in the Big Bang. Why any point in the timeline of the block universe is not a beginning. In the block universe, every event exists simultaneously, which means that all history, including the infinite future, formed instantaneously in the Big Bang. There is no escape from this unless we discard the block universe view of time or the origin of the universe in the Big Bang. These two concepts appear to be mutually exclusive. Next time you look at a tall building or a mountain, imagine that time is running more slowly, even slightly so, near the bottom of these structures than at the top. The stability of these structures depends on the fact that space-time is continuous between areas of slower and faster time. Being slow in time does not lead to disappearing into the past. Imagine if the bottom of a mountain or a building vanished into the past. The theory of relativity predicts the slowing of time with motion and gravity. These predictions have been confirmed in particle accelerators as well as gravity experiments. In gravitational fields, space is continuous between areas of a slower and faster time. If there is a block universe, why do particles and masses with slower time not disappear into the past? The traveling twin, while aging less in the twin paradox thought experiment, does not get behind in the past, although his time is slower. Black holes, with their intense gravity that brings time to a screeching halt, do not disappear from our present into the past dimensions. Slowing of time does not cause objects to slide into the past, suggesting that time is a process and not a dimension. In the block universe view, all moments, past, present, and future, are part of spacetime. But if the universe has a beginning, the Big Bang, this raises the question, why does the block universe start there? The block universe doesn't explain why time seems to have a clear direction, or why the past is fixed while the future remains open in our experience. If the entire timeline of the universe already exists, the idea of a beginning seems strange. What does it even mean for something to begin if all moments are equally real? If only the present is real, and the past is just a record while the future is undetermined, then the Big Bang is truly a beginning in a meaningful way. This matches our everyday experience. We feel like we are moving from moment to moment, and the future isn't out there already. It's being created as time progresses. It also fits with thermodynamics, entropy increases. We remember the past but not the future, and causality seems to flow in one direction. There are some physicists and philosophers who try to merge aspects of both views. Maybe time is a process, only the present exists, but spacetime emerges dynamically as events unfold. Some interpretations of quantum mechanics suggest that the future isn't determined, reinforcing the idea that it doesn't already exist in a block structure. There are models where spacetime grows, like in causal dynamical triangulation (CDT), where spacetime isn't fixed but expands step by step. The idea of a real past, unfolding present, and open future seems much more compatible with the Big Bang as a true beginning, rather than just a coordinate in a static four-dimensional block. The block universe struggles to explain why time starts at the Big Bang. This suggests that time is indeed a real process rather than just a coordinate. This is the end of part 1. In videos to follow, I will discuss a new definition of time. Discussions on the nature of gravity, inertia, length contraction, and twin paradox will follow.